In this lesson, we're going to study something called arc length, which is specifically related to a part of a circle. You'll see that I've drawn a circle. I also have two radii drawn in blue that go out to the circumference of the circle, and I have this outlined portion in red, and that would represent an arc length. Lowercase s is the symbol for arc length. Different curricula may symbolize it differently, but we're going to use lowercase s for arc length. You see I've already written a formula here. But arc length is related to, or specifically related to, the entire circumference of the circle. In fact, the entire circumference of a circle is a continuous arc. So when I find the circumference of the circle, I have found an arc length for the entire circle. But sometimes we need to focus on only a part of the circle, or a segment. You notice I've drawn radii out to the circumference of the circle, two of them, and that really forms this angle, which encloses a segment of the circle. So if we were looking at only this piece, we would, that's usually referred to as a segment of a circle, just so you know the vocabulary. So we're really just looking at this small piece, or this segment of the circle, and we're going to look at the part of the circumference that relates to that segment. So it's enclosed by those two radii that I've drawn, and it's directly related to this angle, as we'll see when we finish developing the formula. So we know the formula for finding an arc length is one-dimensional, so we want to find the length of this arc, which literally, if we were to take a string and stretch it out along the arc and stop it there and measure it, we'd have the length in inches or centimeters of that piece of the circle. Fortunately, we have a formula, so we don't have to do that, and all we need to know to use the formula is a radius, really, and whatever approximation of pi or format of pi we're going to use. You'll recognize this formula that I put on the board. It is literally this part, without what I'm going to put in parentheses, is the formula for the circumference of a circle. So remove what's going to be here, and I could just put the c there. It's pi times diameter. You've practiced that. You know that calculates the entire length of the circle, or the entire arc length of the circle. But we only want to calculate this piece. So we will need to know an angle, a central angle that's related to this arc, or this segment of the circle, in order to finish the calculation. Because it's a fraction of the entire circle. It's a part of the entire circle. It's not the entire circle. So we need to figure out what part of it, what part of the entire circle this arc length represents. So we need to know this angle, theta, and you'll usually be given that. And it's the fractional piece out of the entire angle measurement of a circle, which is 360 degrees. Hopefully you knew that. If not, now you're reminded that the angle measurement for an entire circle is 360 degrees. We've come full circle, 360 degrees. Maybe those are expressions you're familiar with. So the piece of the circumference that this represents is whatever this angle is out of 360. So that piece of the 360 degrees, that fractional part. So now we have a formula for calculating the arc length of any circle. So let's jump in and let's practice a couple. It's really not that difficult. Let's say we're given that our angle measurement is 45 degrees. We're also given that our radius is 12, we'll say inches in this case. So we know two things about this. Angle's 45 degrees, so we can fill that in. We know radius is 12 inches. We need diameter, but if radius is 12, hopefully we know by now that diameter is twice that, so diameter is 24 inches. So we have everything we need to do this calculation. Other than what form of pi are we going to use? And for this one, we're going to say that pi is equal to 3.14. So we're going to use 3.14. The problem or the instructions in the problem will designate what form of pi, whether it's 3.14, 22/7, whether they want you to use the pi button on your calculator, or whether they want you to leave it in terms of pi. Those are all four options that you can see with these problems, so make sure you read the problem carefully. Now all that's left to do is just calculate. So lowercase s, arc length, is equal to pi, which we said was 3.14, times the diameter, which is 24 inches, times theta over 360, so our angle is 45 over 360. And we could put degrees on here. Those degrees are going to cancel because it's the same unit, so it simplifies, and we can just create a fraction out of that. And I would recommend, since this is a decimal number, I would turn this into a decimal. I could reduce this fraction if that were easier, and sometimes it is, but since we're already working with a decimal, we don't want to work in two different number forms. So I'm going to convert that last one to a decimal. 45 over 360 converted to a decimal is 0.125. Do that in your calculator just to practice. 45 divided by 360. That fraction bar also means division, so 45 divided by 360 on your calculator. The mistake people make there is they will enter them backwards and then say 360 divided by 45. It's 45 divided by 360 will give you 0.125. And when you finish that calculation, of course your dimensions are in inches, you should end up with 9.42 inches. For this part, just that small piece, the arc of the length of the circumference, which is an arc length. Let's do one more example. You may already have this. If you do, that's fine. Stop the video and get to work. It's not that complicated. The only real challenging part of these is figuring out what to do with pi often. So we'll show you a different form. In this case, we know theta is 60 degrees. We know that the radius is 9 centimeters in this instance. And we're going to use pi. So theta is 60. Radius is 9 centimeters. So if the radius is 9 centimeters, then my diameter is 18 centimeters, because we know diameter is twice the radius, and I need diameter. And then we're going to use pi. We're going to leave it in its symbolic form. And a lot of times this is a request made in the sciences when you need a more specific answer. You leave it in terms of pi. I shouldn't have said the sciences, because in the sciences you usually want a specific answer, so you'd need a decimal approximation. But in this case, we want to, when they ask for a perfect answer, then they want it left in terms of pi, because every version of pi is an approximation, so you're just getting an approximation. If you use any other form, and use the approximation is good enough, and it's what we need. Most calculation in higher math and science is an approximation, but it's just a really good approximation. So let's go ahead and do the calculation. Again, not that difficult. Lowercase s, arc length is equal to pi, which we're leaving in terms of pi this time. Diameter we found was 18 centimeters. And then the fractional piece is of the full 360 is 60 over 360. And we're ready to go. In this case, I could turn this into a decimal again and multiply, but if I reduce this fraction, which it reduces real nicely, the zeros divide by 10 on top and bottom, it goes down to 6 over 36, which you may recognize is 1/6, so it reduces to 1/6. And see, when I multiply 18 times 1 over 6, it's really 18 divided by 6, which is 3. So I end up with s equals pi times 3 centimeters. So the calculation, in this case, the calculation was a little easier and quicker if I recognized that fraction right away. Has nothing to do really with the overall concept. It just has to do with simplifying math. Now the correct form to write this is 3 pi centimeters. You always put, in math, it's like sentence structure and the way we communicate, but you should put numbers in front of symbols always in your final answer, and then of course your dimension goes at the end, centimeters. So answer is 3 pi centimeters. Again, not that tricky, not that tough. So get to practicing. Hopefully these will go really well for you.